It's my pleasure to introduce you to Dr. Stu Waterman. If you read over his bio, you can tell he's one smart guy. Received his PhD at University of Colorado. And is that where you met him? Yeah, that's. And has worked in the aerospace industry, NASA, you know, what were the other, Canadian Space Agency, European Space Agency. I mean, can you say rocket scientist, you know? Anyways, without further ado, on the topic of air quality, I'd like to introduce Dr. Stu Waterman.
Well, as the technology officer, I felt obligated to have a computer up at the lectern. So climate and air quality, the science, it's, oh, more microphone. There we go. So as you can see, why is air quality a concern? Well, because roughly 8 million people a year die from poor air quality. About 34% of those, excuse me, 34% of those are actually people in less developed countries who use fossil fuels of various sorts to cook inside. So they're cooking-related industries, or deaths, if you like. But 64% of the deaths from air pollution come from either particulate material in the air or else ozone, ground level ozone. We'll talk about that a little bit later. The result on the economy of the world is pretty drastic. It costs trillions of dollars to, and excuse me. So let's look at we'll take a look at the history of air quality and attempts to control it, and the origin of it. We'll also look at things that you can do yourself to manage the air quality in your own personal life and that of your family. So the history of government activity to try and control air quality really goes back to the middle of the 20th century, specifically the Great Smog of 1952 in London, England. 12,000 people died, 4,000 within a couple of weeks of the event, and another 8,000 subsequently as of long lingering diseases that they developed as a result. Oh, sorry. Yeah. So in the US, we had similar problems. Los Angeles, New York, there's a picture of Los Angeles there in the 70s. Primarily ozone problems, but we were doing things like incinerating garbage in the city, having power plants in the city, and the result was dense air pollution and a lot of deaths. So under President Nixon, we started the Environmental Protection Agency, and at the same time passed the Clean Air Act. That was in 1970 in December. Before the Clean Air Act, such actions as did exist to control air pollution were the problems of state and local governments, and it was the EPA's job to bring that under a solid umbrella and manage it underneath, in a same common framework. So the impacts on human health are varied. The World Health Organization believes that air pollution is a public health emergency, with more than 90% of the global population enduring toxic outdoor air at some point during the year. It turns out, there's an interesting fact, every human inhales about 32 pounds of air a day. So air pollution is not something you can easily avoid. unless you can stop breathing. I haven't figured it out, but it would be a challenge, but if you can do it, let us know. In comparison, we drink about 4.5 pounds of water or fluids, and we eat about 3.5 pounds of food. So air is the biggest thing that we ingest and the most important in many ways. Of the particulate materials that we ingest with that 32 pounds of air, the very fine particles are the worst. They are small enough that they can enter the bloodstream, and in the bloodstream they go to every organ in the body, including the brain. And there are a lot of studies going on currently to try and understand the link between various diseases and various problems that are linked to particulate materials. So what the EPA does, they've identified 5 major air pollutants in the United States that they wish to be responsible for: carbon monoxide, nitrogen dioxide, ozone. This is ground level ozone. You probably heard about stratospheric ozone. That's something that we like. That's something that's important. It's a shield between the stratosphere and the ground of short wavelength solar radiation that would otherwise be very damaging to human health. But ground level ozone, which primarily comes from the exhaust of vehicles, is quite harmful, and we'll get to that in a bit. Particulate matter, I've already mentioned, and then sulfur dioxide. So the EPA defines, for each one of those, they define a national ambient air quality standard. And these standards vary over time. They've been steadily made more strict as time goes on, as we get better and better at cleaning the air. The EPA sets the target a little bit higher every time. So they come up with an air quality index, and I won't go into all of this, but it's basically an index of air quality that relates to human health. And it goes from values of air quality, and it's a magic number called 50. It's not 50 anything in particular, it's just an index that they created. Below that, everybody's healthy. Above that, some people will suffer. If you have pre-existing conditions, you might suffer at air quality in the yellow band there. If you're younger and healthier, you could probably survive most of this without any serious side effects. What it's really for is helping you plan your activity outdoors, because this is all outdoor air pollution. There's no discussion of indoor air pollution in the EPA guidelines, although it is a real problem, but not too bad in the United States, so they've let that slide for a while. Now remember these colors, really, that it's the maroon at the bottom. At that level, if you've got that much pollution in the air, that just basically tells you that everybody should stay inside. If you're in the orange band, then only people who are susceptible to some of these problems, such as people with allergies, people with asthma, are good examples. Young children or the elderly. Those are people who will have to head indoors sooner than the rest of us. So particulate matter, that's a human hair drawing this is an EPA figure. It gives you an idea of how small the particles are. They've identified several layers of particulate matter with a diameter of 10 microns or less is PM10, it's not too difficult to figure out. PM 2.5 or smaller, they penetrate deeply into the lungs. PM10 pretty much stays in your upper respiratory area. It's pollen, for example, is a PM10. It stays in your sinuses, your nose. PM 2.5 goes down into your lungs. And then there's ultrafine particles. They're a tenth of a micron. They're literally microscopic. They can easily pass through the lung bloodstream barrier and travel to other organs in the body. They're more numerous per unit volume than any other form of particulate, but relatively rare. So ozone, on the other hand, the other major pollutant, this is ground level ozone again, mostly from vehicle exhausts, industrial emissions, and volatile organic compounds, VOCs. Really, the major source is vehicular traffic these days. Much of the work of the EPA was focused on this particular problem. As we mentioned, the urban heat island effect is a problem of our changing climate. Well, it's this situation inside an urban heat island is ideal for generating ozone, and that's why most of the ozone problem exists in cities and not in the countryside. So in the city, if you have heat, you have clear skies, which you typically get from a high-pressure region over a heat dome, for example. Stagnant air inside the city, all of those things factor together to make an ideal situation to generate ozone. Now, wind can transport the ozone away from the city, but it's typically concentrated inside the city, and of course, so is population. So it's a vicious circle. But the EPA is making some progress. I won't go into don't worry, I won't go into the details of this impossible to read chart. But the important lines here, there's three of them. The blue line that goes down, this blue line here, that's an EPA success story. That's sulfur dioxide. You remember we used to talk about acid rain and problems like that. That's where acid rain developed. And the EPA did a tremendous amount of work, and successfully. I mean, it's now well below the dashed line there is basically where the air quality standard is for each of the substances that they have on the chart. And you can see that for sulfur dioxide, we've managed to take it way down. And we've done that by changing the composition of gasoline in our vehicles, low sulfur fuel for diesel vehicles, and a whole bunch of efforts like that have proven to be really successful. So let's look at information you could actually use. The EPA has a branch called Air Now. At EPA.gov, all this stuff is available. And they basically will, for hundreds of locations, thousands of locations, really, in the United States, they can tell you exactly what the current air quality is, and they can actually forecast where it's going. Sorry. So the Air Now part of the EPA is their public outreach. They do forecasting, or what a weather forecaster would call a nowcast, which takes all of the point source sensors that they have out there, and they take that and fold that with the current weather, wind directions, and so on, and come up with a nowcast, a map showing you the distribution of pollution in the area of interest. And this is Southern California. I picked on Los Angeles because, well, the home of pollution. But these are available easily, and they are constantly being updated through the day. So it's an incredibly valuable resource. The nowcast maps, those individual dots are monitoring points. This is about over Los Angeles, and you can see the distribution of this. In this case, it's ozone is the yellow zone, and you can see that parts of the city are safe to be in for anyone, and other parts of the city, the air quality is sufficiently bad that people with concerns like asthmatics, for example, or people with COPD, they shouldn't go outside. And if you were traveling, you shouldn't go there. So let's look a little bit at climate change and air quality to see how climate change is affecting air quality. I mean, really, the same emissions that we're trying to control climate change are the emissions that we're trying to control air quality. But some of the effects of climate change are the ones that lead to air quality problems. So it's a tug of war, if you like. I think we've mentioned this several times. It bears mentioning again. 2024 is going to be the hottest year on record. It's going to be the first year where the annual average is over 1.5 degrees Celsius above the pre-industrial level. The very first year where the whole year for the entire planet, oceans and land, is over 1.5 degrees. Not a good, doesn't augur well for COP29, but it's something we have to deal with. So the other thing that happens here is the drought induced by heat and changes in precipitation patterns cause problems here because we get dust storms, we get wildfires in dry forests. The record wildfires that we've had in 2023 and again in 2024 actually generate tons of particulate matter and noxious chemicals. And finally, the rising temperatures are extending the range and the production of allergens from trees, grass, plant pollens, mold spores, all of that. So let's look at heat first. So heat, of course, the stress on the human body from heat aggravates any stress you're feeling from air pollution. And extreme heat in the Southwest, I mean, I hear people here talking about, oh, well, it got up to the 90s, you know, well, it's, you know, if you're in Phoenix, that's a cold snap. Phoenix had 70 days this year with temperatures over 110 degrees. And the low temperatures, I mean, the average temperatures for the day were almost 100 degrees. So these are situations where people are in borderline health situations at the best of times. And then, of course, it's also an ideal situation for generating ground level ozone and creating health hazards that way. So heat and heat and ozone production are a problem, but also the fact that also happening in the southwestern U.S. is persistent drought. And that leads to to dust storms, among other problems. And that's Phoenix again. I don't mean to pick on Phoenix. I like Phoenix, but that's what you can imagine the devastating health effects of that wall of sand and dust and particulates that's sweeping over the city. So the drought that worries the desert Southwest with dust storms also leads to wildfires and consequent air quality problems from wildfires in California in particular, in the boreal forests of Canada and Asia. We had the extreme fires that generate the most air quality issues are, are increasing with climate change. These extreme fires, the top tenth of a percent of the forest fires in the planet, we've had about 3,000 of those in the last 2 decades. And they generate tremendous amounts of particulates and chemicals that cause you to think the people we have to really think about in that situation are the firefighters. It's the amount of risk that they take on our behalf is remarkable. And this gives you an idea of how much worse it is with climate change than it has been before. That gray line at the bottom, that's a recent average between 2006 and 2019. And then the subsequent 3 or 4 years, it's just gone through the roof. It won't be as high in 2024 as it was in 23 from the Canadian forest fires, but it will still be at more dangerous levels. And the thing about wildfire smoke, of course, is that it's easily transported. This is a picture of New York in 2023 when the Canadian wildfire smoke came down into New England. And the globe on the right-hand side of that slide shows you the Canadian wildfire smoke spreading around the northern hemisphere. And this is what you get. This is, again, this is the EPA. They include with their air quality information that's available to you. And by the way, you can get an app. There's an app for that, like there is for everything else. But there's an app for air quality from the EPA. And they also include fire and smoke maps in situations that require it. Each of these dots on the map are air quality sensing stations. So you'll notice that some of them, oops, excuse me, wrong button. This is around Philadelphia. These are, you recall that early chart with all of the different colors. We're at almost the top of the scale for all of those stations in the Philadelphia area. And then if you, up here, this is the nation's capital of Canada. This is Ottawa. And that's as high as the air quality, the index there was well over 300. And that's at a level where they just throw up their hands and say, you should stay inside and hope for the best. But you can also, with your app, you can also look at, now one of the useful things here, this is Bend, Oregon. And I was actually in Bend this summer. And if you're traveling and you do have concerns about air quality, perhaps you have asthma and you just, you hear there are fires in the neighborhood, you want to know if it's safe for you to go there, or should you stay home? Well, that's exactly what these are for. You can, again, there's an app, and you can, excuse me, you get the map of air quality stations on the right, and then the air quality report on the left, and you can see this part. This is the time for the measurements that are showing on the map, and this is their forecast for the next, for about 24 hours ahead. And you're going to be in a dangerous situation. Air quality is fine here. Over here, it's going to be a problem. So it gives you some control over your life. We've already talked a little bit about allergies and climate change, and I won't spend a lot of time on it for that reason. But basically, about 26% of adults have some form of seasonal allergy, and about 28 million people have asthma in the United States, and many people have both. We're actually fortunate. 40% of Europeans have some form of pollen allergy. So they're commonly triggered by airborne allergens. These are relatively large particles, so you can see them, right? You can see pollen gathering on your car. You can see it in the blowing through the air. But the combination of allergic response plus being in a heat environment and so on, everything combines and to make your life basically miserable. And this is something that I had never heard of till I started doing the background for this presentation. But there is something called thunderstorm asthma, and it's literally asthma that's made worse by a thunderstorm. What happens here? Well, the most recent example that I found was in Melbourne, Australia, in 2016. A thunderstorm asthma outbreak put 9,000 people to the emergency room, and there were multiple deaths, and the hospitals, as you can imagine, were just overwhelmed, so which causes problems all of its own, of course. So what happens in a thunderstorm environment is you get a lot of vertical air transport, a lot of turbulence, a lot of strong winds, of course. It stirs up, the pollen takes it up into the thunderstorm clouds, the moisture and the lightning and the high winds act to break down the asthma into much smaller, the pollen into much smaller particles. And then those filter down to ground level, and those small particles get deep into the lungs. And that's what spawns the thunderstorm asthma. And of course, we go back to climate change. Climate change is boosting thunderstorm activity just the same way it's boosting hurricanes. Really the same phenomenon. But there is hope for allergy sufferers. There are organizations that are working on pollen forecasting, just like the EPA works on air quality forecasting. The map on the right is a European pollen forecast, actually, developed by the Swiss Meteorological Agency. It's not really an operational thing. It's something that they're still working on. But they have 40% of their population susceptible to allergens, so they have some incentive. On the left, is an output from the Allergy and Asthma Network. They are, as the name suggests, they're people who worry about airborne disease. And they generated a forecast. It's not nearly as comprehensive as the EPA forecasts in terms of the area covered, but there is some effort to forecast situations where if you have asthma, you should stay inside. If you have allergies, you might want to stay inside, or it's good to go outside. So, and that's it. Any questions? Yes.
Two questions. One is, how much protection do you get from being indoors versus outdoors?
That's a really good question.
It seems like there's.
Yeah.
But the other question is, I think you've established clearly the link between global warming and climate change and air quality. The question is, are some of these particulates that are caused by that, are they mitigating for climate change, or do they make it worse? Like, for example, the smoke particles. Do they shield and reflect sunlight, or do they trap, solar?
More the latter.
Okay, so they make it, it's a do loop.
Yeah, in effect,
Okay,
yes.
so what about the indoor-outdoor?
The indoor-outdoor thing is, I mean, the air that's indoors is the same air that's outdoors, right? But it's less turbulent. You have, most houses in particular have air filters in their heating and cooling systems. But fundamentally, it's the same air. So the fact that the EPA tells you to stay inside is of modest benefit. Although, you do get to avoid the ancillary effects of extra heat and so on. So, and presumably you stay, you're relatively stationary, so you're not breathing as heavily. You don't want to go for a run in high pollution, for example, but, that sort of thing. There are excellent filters you can get you might want to, if you're susceptible to the side effects, then you could generate basically a room that was safe for you. But those are, of course, expensive and hardly